Hello and welcome to our SAP Tech Talks webinar. Just a bit of housekeeping before we jump in. This webinar is going to be recorded and it will be available on our YouTube channel. If you've got any questions as we go through the talk, then please pop them in the chat and we'll pick them up at the end of this session. And now let's meet our speakers. Today we're joined by Evgenii Shirokikh and Aliaksei Sachok, and the topic of their talk is Mastering SAP Edge Integration Cell. Colleagues, the floor is yours.
All right. Thank you. And yes, welcome everybody to this Tech Talk. Today, your speakers going to be us. My name is Evgenii, and I'm a lead software engineer at EPAM, exploring, developing, and architecting integration solutions. Around SAP integration, I've been for around 7 years. Was lucky to work with clients of different sizes, domains from retail to healthcare, and manufacturing, oil and gas, professional services, and others. Aliaksei?
Yeah, thank you, Evgeny. Hello, everyone. Glad to welcome you. My name is Aliaksei, and as you might have guessed, I also work at EPAM and as a lead software engineer. And my primary focus is integration. And today I will tell you about the technical aspects of deployment and working with SAP Edge. Thank you for joining us. Evgeny, please continue.
Nice. Yeah, so for today's talk, we're gonna go through some introductory things for you to understand what is it about, what are the use cases, how it's all applied, then go through some architecture aspects, deployment options, and finally see how it looks in some real environment. Okay, let's start, shall we? Now, to start with, SAP Edge Integration Cell is part of SAP Integration Suite. And right now, it's filling this gap of a hybrid integration engine. It means that all the other integration capabilities of Integration Suite, they are cloud, they are built as part of SAP BTP, and this one, Edge Integration Cell, is the hybrid engine that allows to run integration in customer managed environments, such as some private clouds, on-premises, or customer managed public clouds just in Kubernetes. And functionally wise, the Edge Integration Cell is designed as a hybrid integration engine. It means that the runtime is in some edge location, and design time is stays in cloud. It allows to have the integrations as it stands, develop design in the cloud, and it applies to both APIs and integrations as an integration artifact of integration flows. And basically, what it is helping customers have is to finally have this on-premise integration engine, right? Another aspect, maybe just the one important thing to understand about Edge Integration Cell, it's that it's supporting migrations from older integration engines, such as SAP PIPO migration is finally available to have this option to migrate to Edge and not only to cloud integration. What it gives to us having this hybrid engine is integration executed closer to the data source, closer to actual data locations, which results in decreased latencies, increased reliability, and ultimately more control over the environment where it's all executed. High-level architecture is that Edge Integration Cell is deployed in some on-premise or customer-controlled environment. And that means that scenarios such as ground-to-ground integration, when we connect some on-premise systems, such as let's say it's some lead to cash business process, and we have data. We have the warehouse for some retail company, and this warehouse ships goods. It needs to track down all goods movements and so on. And we also know that this system tracking all these changes is some SAP systems that sits also in an on-premise. And in this case, we want to transfer data just within this customer landscape, not leaving the secure perimeter, not going to cloud. And this is ground-to-ground integrations. And if this is in a single region or even in a single country or closer, it's just decreases latencies. It allows localized data processing and more the safer data processing, and in terms of both data privacy and some business continuity scenarios for when internet connections are disrupted, but we still have this connection in place because it does not leave the perimeter. Hybrid integrations is, for example, for the same case, if it's a warehouse and it's shipping the goods, but then it has to be integrated with an external logistics service provider, which has cloud systems. And the hybrid integration means that we are connecting this on-premise, this edge location, with some cloud system, which is again totally possible. It's just a matter of connectivity and having all the proper infrastructure in place to connect it. Internet of Things is another use case. Lots of the cases when the devices, these IoT devices, are located in some closed perimeters in intranet, and we can have this connection established in a secure way with the traffic not leaving this secure perimeter. Another use case I mentioned before, but worth talking a little bit more, is migration for traditional SAP PIPO middleware. This is a previous generation of SAP middlewares, and it's on-premise integration engine. The big thing about such kind of migration is that SAP PIPO is reaching its end of maintenance in 2027 or 2030, and customers worldwide face this necessity to migrate these integrations from SAP PIPO somewhere. And before SAP Edge was a thing, before it became a part of Integration Suite, the options were really limited. The customers could use just the cloud integration and to know such kind of middleware on-premise. Now with the Edge Integration Cell, it's finally available to have such kind of on-premise scenarios. Well, I want to say lift and shifted, but it's not always the case. It's pretty rarely the case, but redesigned with similar kind of pattern of data being processed in an on-premise. Ultimately, it's a really great thing because customers finally have options for which to choose. It can be either cloud integration, cloud native engine, or it can be Edge Integration Cell, or data is processed in on-premise. Let's take a look a little bit deeper on the architecture aspects of this solution. Now, the Edge Integration Cell, it's basically an engine that allows to run integrations in some customer landscape. And again, the design time, it stays in the cloud. It stays within the SAP Cloud Integration or API management. And the only thing that's different from a regular flow of developing such artifacts is that deployment goes, instead of Cloud Engine, it goes into Edge Integration Cell. What it means for some development teams, it means that we don't need any new developers, any new kind of skills for that. It's the same SAP Cloud Integration CPI developers who are trained to develop such kind of things. The only difference in their action is that they deploy it in another runtime. That means that there's no cost for companies to to teach people develop on new technology or to have people trained in other technologies. It's very same development technology, just deployed in a different manner. Zooming in a little bit inside of the Edge Integration Cell. And this is basically a Kubernetes cluster. It consists of different pieces. First is Edge Lifecycle Management. And this set of services, microservices, this is responsible for connecting to the cloud, to this design time space, getting the integrations from there, and some container lifecycle to basically deploy, to set up, run containers, to have this secure tunnel through Cloud Connector. And additionally, two optional services is monitoring through Prometheus and login. Another optional thing is container registry. So it's optional because it's needed for more of a BCP scenarios to have some kind of robustness in place, to have this just the local container registry, like a repository synchronized with the cloud one. Another big thing is runtime and operations, and the central thing here apparently is the worker, is the node where the integrations are executed. The rest, there are other services to make this all work, to enable APIs for internal services, some authentication, authorization, credentials manager. So it's basically just a set of microservices to make it all work, functional and not one functional. Another separate one is a messaging engine based on Solus to enable asynchronous messaging between the components inside. And external to this Kubernetes cluster, it's load balancer, Postgre, just like a database, relational database, right? And Redis as the cache for enhanced performance. For development and test environments, though, it's not necessary. Postgre and Redis can be deployed just within the cluster itself. But yeah, I understand that it has some limitations on performance and it's just for development test purposes only. Deployment options. Right now, what it can be support on EKS from AWS, AKS from Azure, covering wide range of scenarios for big environments, performant with some requirements to latencies. It can be SUSE, and it can be just on-premise Kubernetes cluster, fully managed by the client, by the company. It's also possible. It just means that more of this maintenance and service work is on the client side and not on the cloud providers. But again, that covers a really wide range of scenarios, from just necessity to have this cluster in some private environment to some strict regulatory data privacy requirements. So it has a lot of flexibility, which is a good thing. At this point, when I pass stage to you, Alexei.
Yeah. Okay, thank you. Now let's talk about the technical part of some aspects that we managed to learn during the deployment of SAP Edge on WS. This slide shows the architecture used in our proof concept. We chose AWS, the deployment environment, to test how SAP Edge works in a cloud-based Kubernetes system. And our goals was to gain knowledge and practical experience in deploying and using SAP Edge, and also observe how the system behaves in a real condition. And for our POC, we used two SAP systems, a sender and receiver that have access to AWS environment, AWS environment itself, and of course BTP with cloud integration. And what did we do? We set up our AWS environment and deployed the Kubernetes cluster. Then we activated and deployed SAP Edge within the cluster. After that, we deployed integration flow, which was launched in the Edge runtime directly within AWS cluster, allowing messaging transmission from the sender system to the receiver system. And using this POC, we were able to assess the complexity of deployment SAP Edge in AWS cloud environment, evaluate the requirement configuration, and identify some necessary skills sets for successful deployment. Now let's take a look at high-level steps that need to be taken to successfully deploy SAP Edge on AWS. And first of all, to deploy SAP Edge, you need to prepare your PC. For this, you will need the following tools: Amazon Web Service command line interface for management AWS resources via the command line, and Kubernetes command line tool for deploying and managing application in a Kubernetes. Amazon EKS command line tool for deploying and managing Amazon EKS cluster. And these tools allow you to interact with AWS and Kubernetes services. Let's move on. The second step is to prepare AWS environment, which is an important foundation for deployment. In a practice, we found that most configuration should be handled by AWS administrator. This includes setting up roles, deploying the Kubernetes cluster, activation, configuration of some add-ons such as Elastic Block Store and Elastic File System, configuring a virtual private cloud, and defining security policy. It is also important to allocate the sufficient computing resources. And once we have deployed and configured AWS environment, we can move to configuring and deploying Edge side. There you will need two users, a technical user with a required permission, and as user with the permission to use a repository-based shipment channel. Next, we need to activate Edge cell inside our integration suite. After that, by following the wizard step by step, you will need to specify our users, configure certain settings related to SAP Edge functionality. As one of the final step, you will need to download the kube configuration file to your PC using the command line. This file is required to create the final Edge deployment configuration. After the wizard generates the Edge config file based on your kube file, you will be able to use Kubernetes command line tools to deploy it in your cluster. And once you execute the deployment command in a AWS console, you will see the process running, and if your deployment ended with some issue, then you can check the logs directly on the page of your Edge. However, based on our experience, it is most informative to check status directly in AWS console, because this allows you to get a more detailed information about potential issue related to permission, misconfiguration, and lack resources. And finally, after successfully completion of these steps, the SAP Edge Integration Cell will be deployed on WS. A little bit later, I will demonstrate what SAP Edge look like in a short video. But now let's take a look at how namespace and pods structured within the cluster. Because this understanding this structure helps you see how different components and services are organized and interact within the cluster. So you see all namespaces and pods that were created in the cluster. And let's start from the left side. This is a two namespaces. Kube system. This namespaces contains core Kubernetes components responsible for cluster operation, such as networking, storage integration, system monitoring. It includes critical services like the Kubernetes API, DNS, and networking plugins. The another one is TO system. This namespace is dedicated to STO service mesh, which manages traffic routing, load balancing, and secure service-to-service communication. And now let's take a look at the namespace specifically used for SAP Edge Integration Cells. They're now highlighted on the right side. And the first one is Edge ISIL services. This namespace contains backend services that support SAP Edge, including PostgreSQL for data storage, Redis for caching, and the message broker for internal communication. Below is Edge ISIL. This is the core runtime namespace where SAP Edge executes integration flows, manages API, and processing its data. Key components here included the API management, event controller, and worker pods. The next one, Edge LM. This namespace ensures that SAP Edge components are properly deployed, configured, and updated over time. It includes operators that manage the health and automation of Edge services. And the last one, Edge ISIL ELA. This namespace is responsible for event log analysis, capturing and storing logs for monitoring and troubleshooting. These namespaces are created automatically, and the structured organization allows SAP Edge to efficiently manage integration processes, ensuring seamless service communication and maintain system stability within the cluster. And as I mentioned before, let's now watch a short video Although it does not correspond to our POC, we created it as a demo to illustrate what SAP Edge look like and what key aspects for focus on during deployment and operation. Let's start. Sorry. On this page, you can see Integration Suite. We open our runtime. Here on this page, all your integration, all your Edge runtimes are displayed. Here you can manage them, delete, create new ones, and view logs. In our case, only one runtime has been created. On the right side, you can see the key components of our Edge runtime. These are Edge Integration Cell, the core runtime environment, Integration Cell services that supporting services, insurance, smooth operation, Edge lifecycle management. This handles the deployment lifecycle. Istio, the last one, manages traffic routing, load balancing, and security inside Kubernetes. And each of these components is green, and that means that the deployments were successfully and the system is fully operational. Now we are going to AWS console, and as you can see, I would like to highlight it here is that currently SAP does not support Kubernetes cluster version above 1.29. So please keep this in your mind when deploying cluster. Here shown that you need to remember that you will need to configure add-ons for correct deployment, such as Elastic Block Store and Elastic File System. They're required for persistent storage and shared access in SAP Edge. Regarding instance, they should be at least T3 large for proper operation. Initially, we deployed T3 small, but SAP Edge was unable to launch its services correctly due to lack of resources. So always allocate enough resources. Here you see the settings for the auto-scaling group. Is essential for ensuring scalability and fault tolerance of SAP Edge on AWS. And now we have switched to AWS console. This tools was practically useful and identifies the causes of deployment issue. Using a special command, it allows us to check the status of and functionality of various objects and services such as storage class, pods, resources, and much of the on AWS. And yeah, now we are back to SAP Integration Suite. Yeah. As an example, we have created a flow that sends a message to the data store once of the flow is deployed. And this is a very simple flow, just for example, to see how to deploy it in Edge runtime. And now we have the ability to deploy it directly to our integration runtime. Yeah, and we are deploying the flow. And just to note, here deployments, all deployments are carried out directly in the cloud, but the flow and everything connected with it are deploying in runtime. In our case, this is iFlow and data store. And next, we're going to the monitor section, where there were no message previously. And then we're checking the data store, and you can see the message was successfully saved here. I would also like to highlight that SAP Edge can operate even without a connection to the cloud. In autonomous mode, it continues executing integration flow for up to 4 hours. During this period, data is processed and stored locally, and once the connection is restored, it is automatically synchronized with the cloud. And so now let's sum up it, and I'll hand it to Evgenii.
Thank you, Aliaksei, for showing us what is needed to run actually the Edge Integration Cell. Now, yeah, let's summarize what we've seen and what's the purpose of SAP Edge Integration Cell. So the benefits are flexibility, because again, it gives options for both not just cloud, but also some on-premise deployment of integrations, and options are good. Now, another one is scalability. As imagine if you're operating some kind of a e-commerce integrations for a big B2C product, you probably will have heard that what is Black Friday, right? And during Black Friday, the surge in a load can be 10 times higher than a regular, or 100 times higher. And probably you want your business to be not disrupted during these times. And having this edge, having your integrations deployed in Edge integration, you can make sure that you're allocating enough resources, that you're building some flexible, auto-scalable scenarios, allocating more resources for this time and less resources some off-season when there's not much load predicted. Thus, just optimizing costs, optimizing the performance according to your needs. Again, to me, it goes back to flexibility, because the more flexible we are in terms of choosing how to do this, the better. Another one is, as a result, reduce latencies, enhance performance for ground-to-ground scenarios. As it's the data is closer to their source, the processing may happen within the same cluster, within the same availability zone, and sometimes it's a really big problem when for the big company we have just one cloud integration tenant which runs, for example, in Frankfurt in Europe, but the data is being processed in Australia or for some Argentina or Brazil branch of our business. And in this case, just travel for this signal at light of speed. It still takes some time, and it's not zero, and that's a lot. And having this option to deploy this in the on-premise location closer to data, or we can even imagine some architectures when we have multiple edge integration cells deployed in various availability zones in different regions, thus optimizing this like local data processing, reducing latencies when it's needed, and having the better connected systems. Security and compliance is a big thing, and a number of times we've heard something like, no, it's not possible because our InfoSec does not permit that, it's just prohibited, or GDPR thing when we want our data to be processed within specific region. And this Edge Integration Cell can be a way to solve such kind of challenges, to place our data processing and data storage in a specific point. We are finally not locked in with just vendor managed infrastructures, vendor managed locations. And that's again just a choice to support more things. And the hybrid integration scenarios kind of summarizes some other things, as we can build more flexible infrastructures to connect various cloud systems to various on-premise systems with a given level of security, given level of performance and latencies. Another thing, one of the most important things is support for the migration. Support for the migration within the SAP infrastructures, still having the SAP systems and SAP middleware companies want to still use SAP products. And in this case, migrating from SAP PIPO to this pair of cloud integration plus Edge Integration Cell, or even with API management for API scenarios. It's again a great benefit of having this as again just an option for different kind of migration scenario. And that's mostly it for the main content. I just wanted to say thank you to our SAP Competency Center. We supported our POC, supported our work here, and also to our SAP Integration Discipline Head, Alexander Ivanov, who also put his heart in some pieces of this work and helped us along the way. And it's time now for questions and answers. Let's see what we got.
Yes, Aliaksei and Evgenii, thank you so much for this amazing and informative talk. And let's get down to our questions right away. So the first question is, in a ground to cloud setup, when a cloud connector is shown as part of an edge cell, should a new instance be kept if a company is already using a cloud connector, or can the existing one be reused?
Yeah.
As I know, it's just only recommended to use a separate cloud connector instead of current, to avoid potential conflicts and ensure proper integration.
But it's not a hard requirement, right? So it's mostly just to be able to process some loads, or to have this as a separate channel for some higher availability scenarios or BCP. So to me, it's an existing one can be used, and especially for just getting started with this setup, We know that sometimes it takes a little bit of coordination or bureaucracy on complex environments with different vendors managing different parts of the infrastructure. In this case, setup of a separate cloud connector might be not easy. So using of existing one for initial setup, and then seeing what the load is, what the load would be, and maintaining a separate one, it's maybe a good option.
Right, thank you. Yep, please go ahead.
No, it's that was a good question. I don't think we have more formulated questions, yeah, for now.
So colleagues, while you are generating your questions, please let me take a second while I remind you about our social networks. Join our community on other social networks like Facebook, LinkedIn, the We Are community platform, and others. Use the link in the chat. And let us check if we've got any other questions.
All right.
Right.
So
I believe we have no questions left. So let me thank our speakers for this insightful talk. I believe I speak for everyone when I say that we all got quite a lot out of it. So guys, thank you for putting in all the work and making this session super useful and productive. Massive, massive thank you.
yes, and thank you for everybody who was tuning in to us. And I know that sometimes questions pop up after the talk is done, after we're disconnected. So feel free to ping us in via email, via Teams, LinkedIn, any channels you can find us. I'm happy to answer to any questions. And who knows, maybe later we'll do another tech talk on this topic when more scenarios explored, when more work is done. So thank you, everybody.
Yeah, thank you for your
Indeed.
attention. Yeah, bye.
Yeah, thank you, everyone.